All right, 2D. So again, we're going to go through and figure out which one of these methods is going to work best. We're going to think, is it linear? Is it separable? Is it V sub? To me, I see x, y prime, all right? The y prime is linear, equals 3y. Well, that's linear too, plus x to the fifth sine x. So to me, it's like, this thing looks like it's linear, so I'm going to try and do a integrating factor, a mu. First step is to normalize. So I'm going to do two things in one step. I'm going to get this on the left side, so it'll be subtracted. And then I'm going to also divide by x. If I do that, I get y prime. Oops. We get y prime. Minus 3 over x times y equals, now remember, when I divide by x, I got to divide everything by x. So this thing gets down to an x to the fourth times sine x. Okay, so look, it is linear. It's separable, or sorry, it is linear. It's in its normalized form. So I'm going to go ahead and calculate mu. Mu is equal to e to the integral of, I'm going to pull the negative 3 out front times 1 over x. Remember, I take this piece right here. Sorry, I did that poorly. This piece right here, make sure you carry that negative, otherwise it'll mess it up. I take that and I put it in my integral when I'm calculating my integral factor, dx. So that is equal to e to the negative 3 times ln of x. And now I'm going to plug it. So that's e to the ln of x to the negative 3. And then the e to the and the ln cancel, and I get x to the negative 3. You could also think about that as 1 over x cubed. So I'm going to multiply that on both sides. One thing that I'll point out here is that most common error, I think, with this one would be to drop that negative and accidentally keep it positive. And then that would, follow that, right? Boom, 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 right? That's what puts this in the denominator. So I get y prime. All right, 1 over x cubed. Actually, I'm going to do it as negatives because it'll make more sense. So x to the negative 3 times y prime minus 3. All right, so if I multiply this by x to the negative 3, I get x to the negative 4 times y equals, all right, when I multiply this by x to the negative 3, I'm going to get x times sine x. All right, now just imagine I drop the negative. This would be an x to the 7th instead of a x after multiplying. And you'll see in a moment why that would be a major problem. So from here, integrating factor, this derives, make that a little bit smaller, derives to that. And then this derives to that with the negative. So if I reverse product rule this, we take this one, x to the negative 3, the two pieces that derive to the other two pieces. That times that is all prime, all primed is equal to, and now I haven't changed the right side, so it's just going to stay the same, equals x times sine x. Now I can integrate and integrate, just like we did in the previous mu one, and the integration on the left side works really nicely. Oh, I should just say that the reason why I left these as negative powers is because you can see that this derives to that, right? I get the power rule out front. The negative 3 comes out front, and then the negative 3 power drops down to a negative 4. You should always check that. Whenever you're doing these problems, check to see that those pieces derive to each other, because if they don't, then something went wrong. For example, if we had accidentally dropped this negative when calculating our mu and multiplied by an x cubed instead of a 1 over x cubed, then these derivatives wouldn't line up. It's like a self-check within the problem. You should always check that. All right, so let's go down and integrate. When I integrate, the integral cancels with the derivative. So I get x to the negative 3 times y is equal to, all right, so to do this integral, I got to do some integration by parts. So I got my dir side, I got my int side. So x1, 0, sine x. What's sine integrate to? A negative cosine, is that correct? Yep. And then a negative sine x. And then I do my arrows, and I go plus minus, and I multiply. So that left side is going to integrate to negative x cosine x. And then I get a double negative there, so plus sine x. Don't forget your plus c. From here, we need to solve for y. Let's pause one moment in addition. So go back. The last thing when I was talking about if we had made this error with the negative, right? So if I had made that error with the negative, this would be an x to the 7th, which would give me an x to the 7th here, which think about that integration by parts. That would be a long, long integration by parts. I'm not saying that you're never going to get something that has long integration by parts like that, but if you do, it should be like a little bit of like a red flag, like, hey, like I can do this, but this is pretty wild. Should I look back and see if I made a mistake? So this problem has multiple spots in it where it sort of like checks itself for you if you can look for the right things. So one of the last steps here is to multiply by, or to get rid of this piece. So, you know, it's x to the negative 3. What am I going to multiply by? X cubed on both sides. So if I do that, I'm going to multiply this whole thing by x cubed. I get y, because they cancel, equals, all right, so right side multiplied by x cubed. Negative x to the 4th cosine x. Multiply this piece by x cubed plus x cubed sine x. And then plus c times x cubed. I like that form of that one. Maybe you like to move this over so that we don't have that negative in that leading part, but either one is good. I like this better than putting all of this divided by x to the negative 3, because that's just like, it's not a good form. It's got negative exponents and what else? Fractions, and it's just a mess. This is your good form. And we can solve for y with this one, so we do solve for y as I've done here. Hopefully this one demonstrates a couple things for you. Make sure you don't miss that negative. And then check your work as you go along. It does self-check as it goes along.